Sometimes we just can't take the heat anymore and want to drink something so cold that our brain might freeze. So you open your refrigerator, hoping to find something to quench your thirst. But what would you do if there's only ice and nothing else? It's easy. You scroll on your phone and look for a recipe for summer that you can easily do with what you have at home. You will feel that everything fell into place after seeing a straightforward ice cream recipe. Talk about some luck, but even if it couldn't get any easier than boiling something, then letting it cool, and finally freezing the mixture to turn it into ice cream, you couldn't wait to put it in the freezer, even if it was still hot. And you just couldn't wait a couple of hours for the mixture to thicken and solidify, and put your hand inside the freezer to see if your ice cream is ready. To your surprise, it was frozen and ready to be scooped out and eaten in the sweltering weather. Then you begin to wonder why the leftover drink that was still cold that you put simultaneously in the freezer isn't frozen yet. For you, it may be absurd, but in science, it is possible. Everything can be explained by science. Even the question between boiling and cooled water, which do you think will freeze first? Of course, it is the latter, some might say. But remember how we all thought that between the rabbit and the turtle, the rabbit would win the race? It is not always the case. The same with which will be frozen first. In today's episode of Science Curiosities, we will talk about the times when the phenomenon wherein hot water can freeze faster than cold water can be observed. So grab your safety glasses and join us in discovering why this phenomenon happens. Remember to subscribe to Science Times and be always the first one to watch our new uploads. It all started with Aristotle when he stated how fishermen about 2 millennia ago would heat water to get it to freeze faster. Rediscovered by Erasto Mpemba in 1963, a high school physics student from Tanzania, the phenomenon once again became a subject for discussion. They were making ice cream in school when he became frustrated and tried to speed up the process by skipping the cooling process of the ice cream mixture and immediately putting it in the freezer. To his surprise, his mixture froze faster than his classmates who let it cool first. Does this mean hot water freezes faster than cold water? Seemingly violating the law of thermodynamics. For Mpemba and luminaries like Aristotle, René Descartes, and Francis Bacon, it is entirely possible. The Mpemba Effect underwent its first official course of research with the help of physicist Dennis Osborne, who, at that time, was the only person who believed the Erasto student. In 1969, their research was published in Physics Education, where Erasto explained how he discovered the phenomenon by skipping a particular step in their ice cream making process in a rush to get the last available ice tray. And besides, who doesn't get excited by the thought of eating ice cream? After an hour and a half, his mixture was frozen while his classmates were still in the slurry state. His physics teacher told him he was confused because it could not happen. But for young Erasto, he has to know why and get to the end of it. It has long been proven that for water to turn into a solid, it has to achieve a state of equilibrium in which its volume and temperature are steady. And for it to stay frozen, the individual water particles should remain in that state. If you put hot water in an open container inside a freezer, steam is released rapidly on top of the water, decreasing its volume, thus making it freeze faster. And because cold water doesn't evaporate steam, a layer of frost is developed on top, making the middles still stay in liquid form. The ice igloo insulates the water, slowing the freezing process. The convection current that is present when hot water is placed inside a freezer helps speed up the process of everything, as it initiates the cooling of the water from the bottom, not making any insulation. This was all supported in a work done by 2 researchers in Israel, where they stated that hotter systems of water, like a hot liquid, can skip the process of reaching the state of equilibrium. But according to another website, impurities present in a liquid, like the ingredients of an ice cream, dramatically affect how fast or slow a liquid will come to a freezing point. The result would also differ when the container in which you put the hot water is closed. Up until now, there is still no definite explanation of why this phenomenon sometimes occurs. A professor from Spain further states that the result is still heavily dependent on the water vessel and its environment. To summarize, the main factors that can explain the Mpemba effect are evaporation, convection, environment, and 2 other factors affect the freezing point of hot water. First is the supercooling. It was said that as cold water experiences a more supercooling effect that makes the liquid undisturbed, hot water is more likely to turn solid when it reaches freezing. Then hot water also tends to let out dissolved gases in the form of steam more than cold water, preventing any insulation of liquid from happening. Yes, hot water can freeze faster than cold water, but only under specific conditions. The Mpemba Effect stirred the curiosities and thoughts of luminaries and researchers. It heightened their abilities to question existing theories and possibly develop a hypothesis that defies them. Erasto left a great question that will continue to challenge experts in coming up with a definite answer to why hot water sometimes freezes faster than cold water. It may take them a long time, but the question sure can instigate going beyond our limitations. Give this video a thumbs up and feel free to comment below your thoughts about the topic. If you want to see more of our videos, subscribe to the Science Times YouTube channel.